everyone, thank you for coming today. Today, I'm going to talk about my study. The title of my study is that Effects of S-CRISPR mushroom extract on adipogenesis and lipid metabolism. To begin, I will explain introduction of my study. What is S-CRISPR? S-CRISPR's scientific name is Species CRISPR herb. And as you can see in the bottom right picture, the mushroom looks like a cauliflower and appears white in color. So its common name is cauliflower mushroom. And this mushroom is well known for medicinal effect on the immune system, such as anti-tumor or anti-cancer action. And it's also reported that the mushroom has the highest contents of 1,3-beta-glucan among all mushrooms. So, as you already know well, beta-glucan has been shown to anti-tumor or cholesterol-lowering effects in previous studies. So, we believe that the mushroom will improve inflammation and may also alter lipid metabolism. Therefore, the purpose of my study was to investigate if hot water extract of S-CRISPR has anti-adipogenic effects in 33L1 cell and improvement of lipid metabolism in obese mice. To accomplish the purpose of my study, I made two hypotheses. The first hypothesis that S-CRISPR extract will inhibit adipogenic factors in differentiating adipocytes. In the case of adipogenic differentiation, the only action of adipogenic factor, such as CP-beta and delta, induced the final adipogenic factor like CP-alpha and p-gamma. So I examined these adipogenic markers. And second hypothesis that S-CRISPR extract will have lipid metabolism improving effects in genetically obese mice. As you can see in this picture, the obese mice have the genetic mutation in the obese gene, known as leptin. It causes develop obesity. So we use these mice and expect to preventing body weight gain and fat mass and improving lipid profiles. On the next slide, I will explain the design of the cell study. The cells were treated in the serum-free medium and analyzed the cell toxicity by MTT assay in the pre-adipocyte. And then the cells were treated with differentiation induction cocktail with the medium. And after induction, they were further differentiated with the medium containing insulin. And finally, the cells were maintained in the media. And to examine the effects of SC, we treated various doses of SC, and lipid accumulation and glycerol release and western blotting were measured during this period. On the next slide, I show the result of cell study. Here you can see the result of cell viability in SC-treated pre-adipocyte. SC-treated cell viability decreased in a dose and time-dependent manner, but did not exceed IC50. So we had determined SC did not have side toxicity, and we chose these concentrations for following experiments. On the next slide, I show the result of lipid accumulation. Firstly, as you can see this chart, SC-treated cell decreased lipid accumulation in a dose and time-dependent manner, and also we can also see similar decreased TG accumulation. So the result suggests that SC inhibited the accumulation of lipid droplets in differentiating adipocytes. On the next slide, I show the result of glycerol release. At 5th and 8th day, the amount of glycerol release increased in a dose and time-dependent manner. So anti-adipogenic effects of SC were mediated by increased glycerol release. On the next slide, I show the result of the expression of adipogenic enzyme. As you can see this first figure, the 600 doses of SC treated cell decreased compared with the control. At the same time, decreased C-beta expression. And at the same time, the expression p-tau gamma also decreased in a time-dependent manner. So the result suggests that SC suppressed the adipogenic enzyme in differentiating adipocytes. Now, let's move to the next part, which describes the design of animal study. We obtained 5 old OB mice and divided into 4 groups. All groups were fed a high-fat diet for 10 weeks. During 10 weeks, the groups were supplied with as follows. 2 control groups were supplied with distilled water or sibutramine, and 2 experimental groups were supplied with lower high doses of SC. At the end of the study, body weight and tissue weight were analyzed, and the lipid profiles were analyzed in serum and liver. Now we can see the result of the animal study. Here, as you can see this chart, this graph, the body weight was the highest in the HF group compared last from 6 weeks. And as you can see in this table, body weight gain and food intake also were lower in the SC groups compared with the HF group. So the result suggests that the low weight gain rate in the SC groups might be due to both low food intake and efficiency. On the next slide, I show the result of organ weight. As you can see in this chart, liver and various adipose tissue weight of the SC groups decreased similar to body weight. And the next slide, I show the result of lipid profiles. First of all, serum lipid profile and glucose level similar level to the sibutramine group, and hepatic lipid profile also similar reduction in TG and TC level. So the result suggests that SC treated groups improved lipid profiles and glucose level. Now I will end by summarizing the conclusion of my study. In conclusion, first is that as CRISPR extract inhibit adipogenic development in differentiating adipocyte, and secondly, as CRISPR extract was able to prevent fat mass gain and improve lipid parameters in obese mice model. The key point of my study is that as CRISPR extract possibly have a role of obesity prevention. That's all I have to prepare the presentation for today. Thank you for your attention.